Good day, Sir Randy. We are group members Matthew, Gab, and Lee, and AJ. And today we will be presenting our research on parallel integer sort, theory and practice. This study explores limitations of traditional sorting algorithms when dealing with duplicate heavy datasets and presents an optimized solution through a novel approach called dovetail sort.
For introduction, sorting is one of the most fundamental operations in computer science. However, traditional sorting algorithms like radical sort and sample sort face significant efficiencies, especially when handling large volumes of duplicate data. That's why we explore the use of parallel sorting to enhance performance and scalability. The problem and solution is the core problem we identified is the high computational costs and efficiencies of existing algorithms in duplicate-heavy datasets. Our proposed solution is dovetail sort, which introduces a unique approach known as heavy light key separation to reduce redundancy and optimize performance.
So, for the related work, to better understand our contribution, we reviewed existing algorithms. First was parallel radix sort. It's efficient but falters with duplicates. Sample sort is more load balanced but it lacks the specialized efficiency for integer sorting. So, recent techniques like PLIS and IPS2RA also offer improvements but still face challenges with scalability and duplicates. Dovetail sort improves upon all of this by focusing on execution time, stability, and efficiency.
So, and algorithm. Formally, the problem is to sort an array A of a size n using a parallel processing while avoiding redundant operations. We compared radix sort and dovetail sort across various metrics such as stability, efficiency, and time complexity. So, upon checking on the next slide, this is the given example that we've located. And the next slide, another example. So, dovetail sort or DT sort is our main algorithm. It separates heavy and light keys and applies targeted sorting strategies, which minimize unnecessary work. A key innovation here is to use a parallel MSD sort in conjunction with our approach.
So, in terms of the complexity, radix sort operates at big O of n log r, whereas dovetail sort achieves big O of n and the square root of log r, which shows significant theoretical efficiency. We also verify the algorithm's stability and correctness through mathematical proof and implementations.
So, for the parallel MSD sort, so we utilize parallel most significant digit or MSD sort to manage sub-problems within dovetail sort. This allows the algorithm to effectively handle even high-density duplicates in large data sets.
Evaluation. For our experiment setup, we use Visual Studio Code on a Ryzen 5 4600 Hz with 16 gigabyte RAM. We tested with 1 billion 32-bit and 64 bit integers across multiple distribution, uniform, exponential, Zipfian, and bit exponential. Upon the next slide, we then compare the execution time across multiple algorithms.
So, in our illustration, dovetail sorts consistently outperforms traditional methods. Notably, it shows a times 6.3 speed up on average, especially when working with datasets with a high frequency of duplicates.
So for the discussion of results, so in terms of results, Dovetail Sort showed superior performance, proving its efficiency and scalability in real-world conditions. One unique feature of our implementation is the dovetail merging step, which carefully balances memory and processing time when merging subarrays.
In conclusion, to summarize the dovetail sort significantly, uh, dovetail sort significantly enhanced sorting performance for duplicate heavy datasets while maintaining stability. Compared to radix sort, sample sort, and PLIS, it showed much faster execution time and better resource utilization.
So for our contributions, it includes the improving of parallel processing efficiency, scalability, and optimizing sorting in high duplicate datasets, something highly relevant for big data applications.
AJ.
Mhm.
For the conclusion, you.
Okay, wait. For conclusion,
Future.
to summarize, Dovetail sort significantly enhances sorting performance for duplicate-heavy datasets, while maintaining stability compared to radix sort, sample sort, and PLIS. It showed much faster execution times and better resource utilization.
So for future work and recommendation, for future improvements, we recommend implementing dovetail sort on GPU architectures to increase speed, further adding to dynamic optimization for different data characteristics and exploring memory optimization for better scalability in large-scale systems.
So our next is the demonstration of our code. So as seen here is that we use Visual Studio Code and our main language is Python. So as we run our code, it directly shows the result with the merging and the pivot and then the final result at the last. That is all. Thank you for listening to our presentation.
So for the closing altogether, thank you for
Thank you for listening,
There,
sir.
that
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 concludes
concludes
our
concludes
our
presentation.
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 We're now
We're
open
now
to any
open to
questions
any
or
questions
feedbacks
Our
you may
or
feedback
have.
you may
feedback you may have.